Hello Algebra 1. Today we are starting our new unit, Unit 4, and we are going to be discussing modeling with a system of equations. So the only thing we're doing today is going to be setting up equations. We're not actually going to be solving any of them. So this does involve a lot of reading and then creating equations to make sense of these situations. So here we go. Sammy and Jillian are going shopping for holiday lights to put outside at their houses. Sammy buys 3 strings of blinking white lights and 5 strings of blinking color lights for $81. Jillian buys 10 strings of blinking white lights and 4 strings of blinking color lights for $118. How much does each string of lights cost? So our first question is what information we are missing. And we can see that by the question at the end of this situation. We are missing how much each string of lights costs. So I'm going to say the cost of the lights. That's the information we're missing. Now we know the total cost, but we don't know the cost of each individual type of light. So we're going to let W equal the cost of the white lights. And we're going to let C equal the cost of the color lights. Now, this next question asks, what is an equation we could write to express how much Sammy pays? So let's go see what Sammy bought. Sammy bought 3 strings of blinking white lights and 5 strings of blinking color lights for a total of $81. So she's getting 2 types of lights and together they're $81. That means we're going to have a plus in our equation. We're also going to have it equal to 81 because 81 is our total. So she got 3 strings of blinking white lights. Blinking white lights, the cost of them is W, so I'm going to put a 3W. And 5 strings of blinking color lights. Again, we don't know the cost of the blinking color lights, that's just C. And this would be our equation. 3W plus 5C equals 81. All right, so we're going to do the exact same thing for how much Jillian pays. Jillian has 10 blinking white lights, so that's 10 times the cost of the white lights. And she also gets 4 blinking color lights. So 4, and the cost was C. And together, so a total, she spent $118. Okay, so this is called a system of equation. A system of equations are 2 or more equations with 2 or more variables. Now, we are going to focus on 2 equations with 2 variables, but technically you could have 3 equations with 3 variables. Sometimes we use this symbol here, and we put the 2 equations together. Okay, so this is my system of equations that I have written for the previous problem. And again, we call it a system because there are 2 of them. In this next unit, we will be learning how to solve these equations, but for now, we are just writing the 2 problems. Okay, so here are some steps for writing a system of equations. Sometimes we can cross off information that we do not need, and it also helps to box any number representing a total. So read the problem carefully and actually understand what's happening. Identify what you are looking for and assign your variables. And then we'll write the equations to model the situation. All right, so let's try it again. Number 2, FBLA and Student Council are going to different leadership conferences this weekend. So this is, some important context, but we're not going to actually use anything in this sentence. So if you want, you can go ahead and you can just cross it off. Okay, it might help some people to cross this off. It might make it more confusing looking, so really do what's best for you. All right, but we're focused on where the numbers are. FBLA uses 3 buses and 2 vans to go to their conference and send a total of 110 students. All right, that's a total. I'm going to go ahead and box it. Student Council uses 4 buses and 5 vans to go to their conference and send a total of 170. Okay, I'm going to box that too. That's a total. Now, instead of crossing things off, some people might just prefer to highlight. It's also a little neater. but again, whatever works for you. So we want to know how many students fit on each van and how many students fit on each bus. So step A, what are we looking for? Okay, so look back at the question. Find where the question mark is in the problem. And it's asking for how many students fit on each van. Let's say how many in a van. And we're looking for how many fit on a bus. This question tells you what our variables are going to be. So I'm going to say that V is the number of people on a van. All right, because that's what the question is asking. So the question that is asked tells you what your variable should be. And I'm going to call B the number of people on the bus. Okay, and now I'm just going to look at each situation. FBLA uses 3 buses, so that's a 3B, and 2 vans, that's a 2V, and it's equal to your total, and your total was 110 students. Okay, so that's your first equation, and then student council uses 4 buses, 4B, and 5 vans, 5V, and their total is 170. So that's what our equation is equal to. And there you go. That's your system of equations. Okay, again, we will learn how to start solving these tomorrow. All right, so now let's try a different type of equation. We have the lupines, a family of werewolves, are heading off for vacation in the woods of Transylvania. Uncle Harry Lupine has rented a total of 12 movies and games. Okay, that's a total. I'm going to box it. 12 movies and games to amuse the kids on the trip. Uncle Harry wants them to do some math on the trip, so he tells them games rent for $4.50 each and movies for $3.99 each. The total was $49.92. All right, that's another total. I'm going to box that also. How many movies did I buy you? How many games did I buy you? This problem is different because our total are 2 different types of quantities. Okay, so before, like with the problem above, your total was each talking about number of students, but here our totals are different. So identify the 2 numbers that represent your totals and what they are totals of. The first total is 12, and 12 is the number of items bought, right? The number of movies and games. Whereas the second total is $49.92. Whoops. This is the total cost. All right, so notice these are 2 different units. One is a number of items, one is talking about money. So that will change how we write our equation. What are we looking for? Identify your variables. So again, go find the question mark in this paragraph. How many movies did I buy you? So I'm going to make M the number of movies bought. And how many games did I buy you? Okay, so G, I'm going to make the number of games bought. All right, so this first one is a little tricky for people. We know that there were 12 total items bought, and this was only made up of movies and games. So our first equation is actually going to be M plus G, which is the number of movies bought plus the number of games bought equals 12 total items bought. All right, so this one is talking about how many items we bought. The second is going to be equal to $49.92, okay, because that's our other total. $49.92 is talking about money, and so the other numbers that you were given that represent money, those will go in the same equation together. Games were $4.50, so this will be $4.50 G, and movies were $3.99, so this is going to be $3.99 M. And if you want your letters to match, we can actually switch this to be G plus M instead of M plus G, but it doesn't actually matter. What does matter is that the $4.50 is with the G and the $3.99 is with the M, because that's the cost of the game and the cost of the movie. Okay, and that is it. That's your system. All right, let's try another one like this. Last year you mowed grass and shoveled snow for 10 households. Okay, this is a total. It didn't say total, but this is how many households you mowed and shoveled for. You earn $180 per household for mowing lawns for the entire summer and $200 per household for shoveling for the entire winter. If you earned a total of $1,880, okay, that's another total. I'm going to box it. How many households did you mow and shovel for? All right, so again, identify the two numbers that represent your totals and what they are totals of. Okay, our first total is 10. This is the number of households, or the number of houses you mowed and shoveled for. And our second title is the 1880, or 1,880. And this is how much money we earned. Total money earned. All right, what are we looking for? Again, look for the question mark. How many households did you mow and shovel for? So I'm going to make M the number of mow, and I'm going to make S the number of shovel. And these again are for households. Okay, now we're going to write our equation. So again, we're going to have 1 equal to 10 and we're going to have 1 equal to 1880 because these are our totals. So 10 is the number of total households. That will just be M plus S. The number of mowing houses plus the number of shoveling houses is 10 houses altogether. And then for the 1,880, that will involve how much money you made. So the money goes together. The 180, the 200, and the 1880. We mowed for $180, so that's going to be 180M. And we shoveled for $200, so that's going to be plus 200S. And that will be equal to your 1,880. Okay, again, notice how these three values are all money, so they're going to go together. All right, so now we're going to learn how to write one more type of equation. This system has an equation in slope-intercept form and standard form instead of two equations in standard form. Okay, so all of our equations so far have been in standard form. If you remember, standard form is when our x's and y's are together on the same side. Of course, we're using different letters than x and y in this case, but they are still together. Slope-intercept form is where we have our y equals mx plus b. We're still going to be using different letters, but we're going to have a variable equal to something else. All right, so before we do a system, let's practice translating the following sentences. Let's give it a try. M is 4 more than B. So here's what you need to know about translating. This word is always means equal. Okay, so you're going to go in order. It says M, so I'm going to write down M, is means equals 4 more than B. That means that you're taking B and you're adding 4 to it. 4 more means we're adding 4. All right, let's try it again. Y is, okay, here's that is, make sure you put it as an equal. 3 times x. All right, bring down your y, is means equals. 3 times x, that's multiplication. We're going to write this as 3x. Okay. Z is, all right, again, that's your equals. 2 less than W. 2 less. So 2 less means we are subtracting 2. Make sure you put the W first. All right. D is, all right, that's my equals. 10 less, than 5 times x. All right, this has two things going on. 10 less than 5 times x. We have subtraction and multiplication. So 10 less means you're going to have a minus 10 over here. 5 times x, we're going to put that there. So 5x minus 10. B is, all right, again, every time you see it is, that means equals. 8 more, 8 more means addition. Go ahead, put your plus 8. Than 3 times L. That's 3L multiplication. All right, and finally, C is, again, is means equals. 5 less than 2 times M. 5 less, we're going to put minus 5. 2 times M is 2M. All right, so now let's see how this helps us. The sum of a small number and a large number is 186. Sum means total when we add. So this is a total right here. The large number is 6 more than 3 times the small number. Okay, we got some numbers in there. Find the small and large numbers. All right, again, sum means it is your total. Variables. There isn't a question mark here, but they do tell you at the end, find the small and large numbers. So S is going to be our small number, and L is going to be our large number. When you write your system for equations, or system of equations, the word you want to look for these is the word than. When you see than, this tells you you're going to be translating, just like we did on the previous page. Okay, the first equation is just like we did in the previous type of problem. 186 is our total. We're going to add our small number and our large number, and our total is 186. Okay, the second equation involves our translating. So when I read this, the large number is 6 more than 3 times the small number. This tells me I need to go back to the start of the sentence and begin translating. The large number, that's L, is, that's equals, 6 more means we're going to add 6, than 3 times the small number. Again, the small number is S. 3 times means we're multiplying. So 3S. This becomes L equals 3S plus 6. All right, and we can see how that looks similar to slope-intercept form, y equals mx plus b. And this is your system. All right, let's try one more like this. The sum of a small and large number is 22. Again, that's going to be your total. That's the sum. 2 times the large number minus 3 times the small number is 46. Find the small and large numbers. Okay, now this one didn't have that word than in it, but this is still an example of one that we will be translating. Find the small and large numbers. Those are going to be your variables. S is the small number. L is the large number. For our system, again, 22 is your total, so we're just going to say S plus L equals 22. And then we can translate this blue sentence. 2 times the large number, that's 2L, minus, okay, that means subtract, 3 times the small number, that's 3S, is, so that's where your equals goes, 46. All right, and there you go. That is your system of equations. Have a great day.